So fine, anomalous properties of second period element. So it means to say what is the peculiar characters of the second group element. It means to say lithium, beryllium, boron, sodium, magnesium, aluminum. So how it will behave by themselves, how it will interact. So this is the thing. Rajesh, I'll tell you what to do, what to not to do. I'm not calling any Zoom classes. I won't call any Zoom classes tomorrow for the test. So, okay, anomalous behavior of second period element. It means to say that in the second period, so you know that what are the elements is present in the period, second period. So there is hydrogen here, helium, lithium. It starts from lithium. So lithium like this, beryllium, boron. So this are seems to be as second period element. So we have 18 period, right? So second period elements are seems to be showing an anomalous behavior. First, you should know what do you mean by anomalous. Anomalous means it will showing an different kind of property. For suppose example, if hydrogen and your sodium, potassium will comes into the same period, it means to say that in some cases it will have same properties. For example, if it need to react with an oxygen, the productivity will be the same. So like that, if you are seeing any other properties, so other than the metal, oxygen to react adaga, it might have given metal oxide ಕೊಡಬಹುದು. So that is a similar properties for all the metals. But in second period elements, what they were saying, whatever the element that it doesn't show and similar properties among them. Okay, it doesn't show and similar properties among them. It means to say that andre ಯಾವುದೋ ಒಂದು physical property, if it's supposed to be in one of the physical property, if it shows it will give metallic oxide. For example, oxides for your any one of the element, the other element in the same period, it doesn't show or it might have not show that same oxidative property. In the simple agreement, if I need to simplify, if lithium combines with oxygen, it will give lithium oxide dioxide, LiO2. If manganese, MgO2. So dioxides, these are dioxides. But suppose copper, it will give copper monoxide. So see, here these two will form dioxide and this is forming monoxide. So it means to say the elements that are present in your second period that have not having the similar properties, either it may be in physical or it may be in chemical properties. So it means to say it's have its own properties. It doesn't combine with other element by sharing their similar properties. Because of that, it's showing anomalous behavior. That is called as anomalous behavior. Each elements will show and different categories of properties and different zone of properties. That is called as anomalous behavior. Got it? Anomalous behavior ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಆಯ್ತಾ? ಬೇರೆ ಬೇರೆ ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನ ತೋರಿಸುತ್ತೆ, ಸಿಮಿಲರ್ ಪ್ರಾಪರ್ಟೀಸ್ ಇರಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ as anomalous behavior. So now in the group first, lithium and beryllium. Okay, lithium and beryllium. So if you are considering the metallic properties of these two, if you are considering a metallic property of this, ಇವೆರಡರ metallic property ನೀವು ನೋಡೋದಾದ್ರೆ, so these are an alkaline metal. ಇವೆರಡೂ ಕೂಡ alkaline earth metal ಆಗುತ್ತೆ ಅಲ್ವಾ? alkaline earth metal. But alkaline earth metal ಆದ್ರೂ ಕೂಡ it doesn't having the like metallic property. So it seems to be unlike. So hey, how you can say that it doesn't showing the same metallic property? It means to say that when oxygen react with your lithium, it will give like lithium oxide, that is metallic oxide. But beryllium, it doesn't form a metallic oxide. Beryllium doesn't form an metallic oxide. This is the basic nature of the metal. So by this statement, we got to know that the diagonal relationship of the second period elements, the diagonal relationship. What do you mean by diagonal relationship? Supposed to be this is first and opposite like this. Second period ಅಲ್ಲಿ ಕೆಳಗಡೆ ಇರುತ್ತಲ್ಲ. So these two are diagonal. These two are diagonal. So this diagonal element which doesn't show an similar property. Just a second. Okay, got it? So the diagonal relationship. So if you are going through any other metallic conditions, or if you are going to read any elemental property, what it will do, if you are focused on the diagonal elements ಅಂದ್ರೆ ಇವಾಗ ತೋರಿಸಿದ್ನಲ್ಲ. So first period, first group ಆದರೆ second period, second element. So those two are diagonal elements. So the diagonal element doesn't show an similar property. Okay, but I'll tell you, in the case of S and P block element, okay, in the case of, okay, I'll explain by showing the periodic table. That is much more easier to understand. Yes. So the diagonal properties of S and P block elements. So the diagonal properties of S and P block elements are almost same. For example, you can see lithium and magnesium are diagonal. Sodium and calcium are diagonal. So these are showing the same properties of physical and almost chemical that's interacting. So if supposed to be second period elements means to say this one: beryllium, manganese, calcium, strontium, barium. Okay, this properties or this element which doesn't show an similar properties, that is called it as enameller behavior. Okay, got it? Artheta. So they'll ask you for 2 marks, like write the anomalous behavior of the second period elements. Baritira alla? Will you write? So then the chemical reaction. So how it will react means, yes, of course, the electronegative component will react with the electropositive component, and cation react with the anion, and less charged atom that react with more charged atom. So like that it will react. So then metal react with non-metal and by forming a bond. So this all the things will comes under about the chemical reactivity of the trends. Okay, this is the last concepts, and by this statement we are end up with this lesson. So now you need like you asked me to explain atom and all, right? Like tomorrow's test. Okay, within 5 minutes I will finish. So see, so atom is the smallest particle that surrounds by an electron. So electron or the negatively charged particle, so and that has a space, a fixed space called a proton, that is positively charged particle. The electrons are revolving in the imaginary line that is called orbitals. So then that orbitals are seems to be KLMN. So each orbital have its own shells, that is SPDF. and each shells have its own subshells. That is S having one subshell, P having three subshell, D having five subshell, F having seven subshell. Each subshell having the capacity of sharing the two of its electrons. So that's why S can taken two electron, P6, D10 and F14 electron it can accommodate. Next. So this is about this. So electronegativity means electronegativity. The element which having a less atomic size and more attractive force, and if it drags the electron from the other atom, that is called electronegativity. So the electronegativity means the atom will drag the lone pair of electron from the other atom, that is called electronegativity. And electropositivity means the atom which are readily lost the electron, that is called electropositivity. So the electropositivity will always combine with your electronegative atom. And metal, we have metal, that is S block elements. It's call it as an alloy. The first group is called as an alloy, and first period is called as an alloy. Second period is called as an alkaline earth metal. So alkaline earth metal, and P block for non-metal, and your D block element is called as metal. So D block element will show the intermediate behavior of S and P block. So that's why it called it as inner transition elements. And we have DD transition. DD transition means to say the electron will jump from the inner subshells of the D block elements. That is called DD transition. And we have F block elements. F block elements, it's just an intermolecule picking from the D block element. It means to say it's a continuity part of your D block elements. So that's why F block element is called as inner transition elements. So then electronegativity is based on the how much atomic size. It's depend upon the size of the atom. So if you're seeing chlorine having a more electronegativity than bromine having a more electronegativity than your iodine having more electronegativity by your oxygen. So because of the force, based on the force of the center of the atom, we are going to say which one is more electronegativity and which one is more electropositivity. The one you have more electronegativity than chlorine, that is called fluorine. So if these components are intergiven, so for example fluorine combined with oxygen, what happened? Your fluorine having a more electronegativity, that's why it will attain the minus charge, and will oxygen attain the plus charge because of the more electronegativity. It means to say fluorine will drag the electron from the oxygen, that's why it will become negative charge. Then what I did, then any other concepts?